example, we're looking at 108 randomly selected college applicants. The following frequency distribution for exam scores was obtained. So from here, we have to fill in the gaps that are missing in this chart. They give us the class limits and the frequency. We have to come up with the class boundaries and midpoints. So how do we do that? The class boundaries, if you recall from an earlier example, are going to be half a point under this, half a point above this. So this would be 89.5, okay, to 98.5. Now, the next one starts out with this exact one. Whatever the last one was for the previous, that's where this starts. So 98.5 to 107.5. And again, this next one's going to start with 107.5 to 116.5, and this keeps going. I get 116.5 to 125.5, 125.5 to 134.5, okay? Now, the next part is asking for the class midpoints. How do you find that? Well, you want to add your class boundaries and divide by 2, that's it. So I'm going to do this down here. So it would be 89.5 plus 98.5 all over 2. And then that ends up giving me 94. And so I do this for all of them. I get 94, 103, 112, 121, 130. That's my class midpoints. Now the next one is the cumulative frequency. Notice, over here I have 1, 2, 3, 4, 5. Over here I have 1, 2, 3, 4, 5, 6. For the cumulative frequency, you're always going to have one more. The reason why, the very first answer is always going to be 0. And over here, where this blank is, less than, it's going to be your lower class boundary, the 89.5. And then you just keep writing the others. 98.5, 107.5, 116.5, 125.5, 134.5, okay? That's why there's always one more. Now, the cumulative frequency, how do you do that? Cumulative means, adding them on as you keep going. So the next one is 0 plus 6 is equal to 6. Why 6? That's the next frequency. And then the next one would be this one, 6 plus the next one, 22, is equal to 28. And you keep going. Then it would be 28 plus 43 is equal to 71. Then it would be 71 plus 28 is equal to 99. And last but not least, 99 plus 9 is 108. This answer here should be the total of your problem. Now that's how you do the chart. The next part of the question is asking us to construct a histogram. The histogram has nothing to do with the cumulative frequency that we use for the OGI. So we just did that for practice. Now let's get started on this histogram. Let's scroll just a little bit so I have all my data. Okay. Now a histogram is what they call a bar graph. Okay. And so you need to make sure you're labeling everything as well whenever you do one of these. So this is my X, this is my Y. Over here, this is the frequency. The frequency is going to be on your left-hand side. Down here, these are the exam scores, what our data is. And here, now your units of measure for frequency is kind of up to you. You want to do them in even increments. You don't want to do 6, 22, 43, 28, 9. You want to do something like 6, 12, 18, 24, etc. That's what I'm going to do. So we have like 6, 12, 18, 24, 30, 36, 42, and 48. And the reason why I stopped at 48 is the highest number here is 43. I wanted to make sure I was a little above that. Now, down here for your X, you're going to write your class boundaries. So it would be 89.5, and then this would be like 98.5, and then this would be 107.5, 116.5, 125.5, and last but not least 134.5. And then from here I just do my bar graph up to the frequencies. So the first one is 6. Okay. Second one is 22. 42. So, you do as best you can in between those. And then you have 43, just above the 42, best as possible. It might be a little bit too high. Then you have 28, so about like here. And then last but not least, you have 9, so it's in between those two, something like that. Maybe a little higher, like that, okay? That is my histogram for this data. Now let's move on to the next problem, which is about stem and leaf. Okay, let's talk about stem and leaf plot for this data set. A stem and leaf plot takes a number, and I'll give you a couple examples, takes a number like 17, and like let's say you had 17 and you had 18. Well, we consider the ones to be the stems, and we consider the numbers after to be the leaves, okay? So you might be asking, what happens if I have a number like 100 and like let's say 103? Well, then your answer would be that your stem is going to be the 10, okay? And your leaves are always going to be the single digits there. So let's go ahead and do a stem and leaf plot for this data. The stem and the leaf. Okay. Now, the stems, if we look at this data set, our smallest numbers in the 20s. So my first stem is 2. And I can just go through and do all the stems like now. 2, I have stuff in the 30s, the 40s, the 50s, and last but not least the 60s, and that's where it stops. My leaves, in the 20s, I have the number 22, so I write a 2 for 22, and I have the number 25, so I write a 5 for 25, okay? The next one, in the 30s, I have 34, so there's my 4 for 34, and here's my 5 for 35. You're just writing the numbers this way. Now in the 40s, I have a bunch of data. So I have 41 twice, and I have 46 6 times, kind of ominous here for, this kind of question in math class. Ooh. And then I have 47 and 49. In the 50s, I have 54 twice, and then 59. And then last but not least, I have 60. That's what a stem and leaf plot is. You just take all this data and you condense it into this little chart by, kind of separating off your stems, your first numbers, and then your leaves are your second numbers, or your second place of the digits, sorry, to be more formal. Okay. Let's look at this next problem here. This next problem here is showing the number of calls received by the IRS in 11 randomly selected days. So we need to find all this data here. Now, the first thing you always want to do is go ahead and arrange the data in order. I'm going to do that now. If you look at the data at the bottom, I've gone ahead and arranged it in order. So this makes it easier for us to find the median, okay? And, just to figure that out. Well, the first thing we need to find is the mean. To find the mean, we're going to add up all these numbers and divide by how many there are. Well, there are 11. So I will take that number and divide by 11. So if I add this up, I get 240 over 11, divide it out, and I get 21.82. That's my mean. Okay. Now the median, if I look at this data, I have 11 things. So I need to count 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Which one's in the middle? The number 23. That's my median. The mode is which one appears the most. As I see here, I have 3 25s. That's the popular one. And the mid-range is your lowest number and your highest number added together and divided by 2. So 12 plus 32 divided by 2, which is 44 over 2, which is 22. And then last but not least, the range is the highest and lowest subtracting. So 32 minus 12 is 20. That's my range. So that's how you would compute this for this type of data set, all by hand. Okay, let's look at the next problem. Now the next problem is having us look at another data set. We have to find the range and the variance and standard deviation. So the first thing I want to do to find the range, which is the highest and the lowest, subtracted from each other, is I need to arrange this data in order, and I'm going to do that now. So if you look here, I've arranged the data in order. So I see my range, my highest is 226, and my lowest is 66, so 226 minus 66. This ends up giving me 160, so my answer is A. Now the next one is asking for the variance and standard deviation. If you have a graphing calculator, you can enter this data set using the stat menu, go into edit, and entering in these numbers into the L1 chart. Then you go back to stat, and you go over to math, and you do the, one variable stats, and that will give you the variance and the standard deviation for a problem. If not, you have to use a formula, which is this one here for the variance. Sigma squared is equal to n, the sum of x squared, minus sum of x squared, all over n minus 1. And then to figure out the standard deviation, you just take the square root. So standard deviation is just the square root of what you got from the variance, okay? So how do you find all this stuff? Well, what is this thing here? What is this thing? What is n? N is the total. So in this case, our n is the number 10. All right, this thing, this big weird looking e of x, you have e of x like this, and then you have e of x squared. Now these are two different ones, okay? This is the sum, so this one you add them all up, and then this one you're going to add up all the squares, so you add up the squares. What do I mean? Well, let me show you what they look like, okay? So if I were to do e of x would look like 66 plus 135 plus 136, and I'd keep going till I'm done. The sum of x squared is 66 squared plus 135 squared plus 136 squared, and going on. For something where we only have 10 numbers in our data set, this isn't that bad. But we have had problems in the past where they can get rather large. You might have 25 things of data, 25 numbers here. And so that gets to be a little bit time consuming when it comes to adding them all up. So if I work this out, my sum of x ends up being, this one ends up being 1596, okay? And then my sum of x squared is going to be a bigger number, and I end up with the sum of x squared being this huge number here. Then I go back to that formula, and I put this all in. So the first thing in the formula is n, so sigma squared is equal to 10, that's my n, that's how many there are, that's what that means, the total. And then I have this thing here, the sum of x squared, so this big number, 272,582, minus, now this is the sum of x, and then I'm going to square it, 1596 squared, okay? And then over 10 times 9. Then from here, I would take this, if I don't have a graphing calculator, and I do this in my calculator. And what I should end up with is my standard deviation, my variance should end up being this last one here, 1,984.5. And then I take the square root of that, so I get sigma squared is equal to 1984.5. And then to figure out sigma, I just take the square root of that. Okay, and that ends up giving me 44.5. If you could possibly borrow a graphing calculator from someone, that's going to be your best bet on this exam, or in a future exam as well, because like I said, they do get to have a lot more numbers in the problem. All right, the very last one here has to do with Chebyshev's theorem. So the mean of a distribution is 20 and the standard deviation is 2. At least what percentage of the values will fall between 10 and 30? So this is the one that has to do with k. The formula is 1 minus 1 over k squared. All right, that's going to tell you what percentage you're looking for. So how do we find k? What do we do here? So the first thing I need to do is take the highest and the lowest, and I need to subtract them, and I get 20. Oh, I'm sorry. Hang on a minute. Did that wrong. I need to take the highest okay? And the mean, so the highest minus the mean, which is 30, minus 20, which is 10. I was thinking backwards, okay? Then I find my k. To find k, it's this number here divided by the standard deviation, all right? So 10 over 2, so this comes from that. This is the SD, standard deviation. So in different problems, it's going to be a different number. 10 divided by 2 is equal to 5, so I know that k is equal to 5. Now from here, I just plug this into this formula. 1 minus 1 over 5 squared. Well, what's 5 squared? 1 minus 1 over 25. I do this in a calculator. This is a fraction now. And I end up with 0.96, or 96% of the data is going to fall between the numbers 10 and 30. Let me quickly explain why this makes sense. You have not probably seen the bell curve, but what this is trying to say is that, you have this, I'm going to draw it real quick. Here is your mean of 20, all right? They want to know how much of the data is going to fall in between 10 and 30. Well, even though it doesn't seem like this would be possible, 10 and 30 are going to be very far out here. How do I know that? Because the standard deviation is 2. So I would have here would be one standard deviation, 22, 24, 26, 28. Well, I kind of overshot that. Really, 30 should be more like here. Sorry. That. This should be 30. And then this would be 18, 16, 14, 12. So again, I got to move the 10 out right here for the 10. So really, a majority of the data, in this case, is going to fall in between these numbers. That's why it's 96. And the reason why that is the more you go out with standard deviations, okay, the more people you're covering. For instance, majority of people usually fall within 1. Most people fall within about this much. 1 standard deviation. So if you think about IQ, if the average is about 100, most people are between 80 and 120. Anything below, you start getting to be people who are, developing disabled mildly, and then furthermore severely if you keep going down. And then if you go above, you get people who are smarter. So you get your smart people, then you get your geniuses, then you get your Sheldon, Cooper from Big Bang Theory, you get your Einsteins, and so on. So that's why this number is 96%. That's why it's so big, okay? It's kind of giving me a little tangent there, but this is how you do the Chebyshev theorem. I hope that you get something out of this review. Your best bet is to practice. Practice this, review that I've given you. Practice what your teacher's given you. Look at homework problems that you've had. These are going to be your best bets in preparation for the test. Please try to borrow some graphing calculator. As this class goes on, it will get more difficult to do it by hand without one. Trust me on that. I'm an expert. I do not like doing it by hand, and I, at some point, just don't even want to. So it takes up a lot of your time, and it's very unnecessary if you have the opportunity to borrow a graphing calculator from a friend or a relative, something along those lines. Hope that you do well on your test, and thank you for watching. Good luck.